Hi, my name is Denisse. I'm going to be showing you how to access some NESP datasets. We're going to be using the Seagrass Dataset as an example today. So we're going to go through these for several notebooks. First, we're going to show you how we connect and just do a simple visualization. And then we're going to create maps that involve aggregation of data. And we're going to show you how to do this more efficiently. So let's start with this, the packages that we're actually be needing for this script. So we're going to be using Arrow, which is the package that is going to allow us to connect to the actual datasets that are stored in an S3 bucket. H3, which is an indexing system, geospatial indexing system that will allow us to aggregate data very easily and also map it very easily. Then we're going to use these three packages here, dplyr, tidyr, and stringer, that allow us to manipulate the data, get it ready for plotting, and then plotting ggplot2, you might have heard about it, and then leaflet, which essentially just allow us to create interactive maps, which are really cool. So anytime that you want to access any NESP datasets, you will use this same code, essentially. The only thing that will change really is the URL that is unique to each dataset that you want to use. So again, we're going to be using the Seagrass dataset for this example. So first we connect to the bucket. This is basically the parent folders, so where all the different datasets are stored. We set this anonymous to true because we don't actually need any login details, it's just publicly accessible. And then the region, which is just basically a location of the server. It's going to, this section here is always going to be the same. So then this will allow us to create a connection. And once that's established, then we can provide the URL for the unique dataset. In this case, as you can see here, is the Seagrass. And it's a Parquet file, so it's kind of like a CSV, but much nicer. Very efficient and easy to access and load in your system. And then we open the dataset, we need to provide the URL, which we define here, and then we need to make sure that we provide the connection to the S3 bucket. Then if we print the DS, the dataset that we store, it's not actually going to show us any data, but it's going to show us what we call a schema, so the structure of the dataset. We can see how many files there are in this particular dataset. The Seagrass one only has one, and it gives you the name of the actual dataset, which is Seagrass. Then once again, if you don't print DS, you can also access DS schema, and once again, it will give us the structure of our dataset. So each name here refers to the name of a column. We have 21 in total, but we're not really sure how many actual observations there are in there. But that's fine. We can just query dimensions, which will give us the number of row spares. So that's about 3 million, just over 3 million, and then the 21 columns. So by kind of calling this dataset with the connection through the arrow, we are lazy loading the data, which means that it will kind of like stay in the cloud until we need it. And only when we call it, it will actually be loaded into the computer. And the good thing of doing this is that if you have limited memory in your computer, it won't crash it. But then we can actually load it, the whole thing if we want to, using the connect function. So it's very simple. We just give the location of our dataset, which we call DS, and then connect. That will actually load everything. So if we now call df, which is the data frame that has been loaded into the memory of our computer, then we can see that this has 21 columns, and it's only showing us 6 rows in here because we are just wanting to see the first few. In this case, it defaults to 6. And then we can have a look at the contents of that particular data set. We can also just extract a year. So let's say we're interested in 2025. We can do that. We just go start year, so the year that they started doing the collection of data. We filter. We finish with collect every time that we actually want to load anything in the system. And then we see that the dimensions return at 25 and 21. So again, 21 columns, and that's only 25 records. So that's a lot more manageable for any computer, 25 rows. With the filtering, you can use basically any dplyr verbs, but you can look at the documentation, just go to the error package, which we're not going to cover here because it's a lot. So we're going to have a quick look at the kind of like the amount of data that we have in this Seagrass dataset. So in here, we just go, basically, we just want to extract any unique records of or combinations of years and the different datasets that are included in the Seagrass dataset. Then we're going to group it by year and we're going to count them. So that will give us the number of datasets available. So basically, imagine it as like sampling campaigns. So then we just, once we count them, we can just call ggplot and create the plot that you can see here. So then it gives us the number of datasets over time. And we can see that, probably the 60s, 70s, up to the 90s, data collection wasn't that great, but it has been improving in recent years. We can do the same thing for the number of records. So that's not the number of campaigns, but rather the number of observations that were collected by everybody during the campaigns. So same thing, we can just group it by the start year, for example. We can count them, and then we essentially do the same thing. We just create a plot that will show us the amount of observations. We can see here there was a peak in the 2011, and then it dipped in 2016, but then it has gone back up since then. And then these are the number of organisms that are recorded. So to do this, we actually look at the organism quantity as well as the absence and presence, because sometimes we do have information about the individuals, the amount of individuals that were found, but sometimes we don't. So that's why we need to use these two different columns, the organism quantity and the occurrence status, to get or to correct rather the organism quantity column. So 0 if it's absent, and if it's present, we'll give it a 1. We assume that there was at least one. And then once again, we just use ggplot to create another graph like the bar plot that we see here. So that's the number of organisms over time. And we can see that in 2023, there was a peak in there, about 60,000 organisms. And finally, we can just have a look at the new species that we have, or that the people collecting this data have detected over time. So this is kind of like a cumulative sum, but again, of only new species. So the first time we got about 3 species, and by now we have nearly 30. So what we can see in this graph is that the number of species is still increasing. So we probably haven't finished sampling or detecting all the possible species that are occupying this particular area. And yes, then we can keep exploring using the different tags that are provided under the Australian Marine Regions tag. It includes information like the type of ecoregion or the water type, and several other tags that help us classify the spaces that have been sampled in different ways. So in here, we just had a look at the table, having a look at the data sets that are available, the years. These are all the tags that are associated to each observation. And then we can see that there are different types of water that are available. So tropical waters, temperate waters, and like that. So in here we have created essentially not data sets, but plots, giving you the number of data sets available for different types of water. So that will be, as you can see here, cold temperate waters, transitional waters, tropical waters, warm temperate waters as well. So cold temperate waters, not very well sampled, unsurprising. Transitional waters, the best well sampled. We can do the same thing with the amount of records, just like we did before. And then we can do the same with the number of organisms as we did before. In here, you should know that there's a difference in the y-axis. So this one here has a little bit more animals than that one there, or seagrasses rather. And again, this is just how new species are detected over time in these different water types.